Continuing with different types of sampling, the next one I'm going to talk about is cluster sampling. So what cluster sampling is we have our population, and what we're going to do is we're going to pick clusters. So we're going to pick different clusters within the population, and then what we're going to do with those clusters is we're going to survey every single person inside those clusters. Oh, I forgot to mention in the previous video, stratified sampling is great. It does much better than simple random. The problem is that it's, of course, more expensive to pull off, and it's more difficult. Cluster, on the other hand, is a little crappy. So now who might do cluster sampling? I think the textbook had a good example. Let's say you are McDonald's and you want to know how long people tend to wait in line. So McDonald's has, of course, thousands and thousands and thousands of restaurants all over the world, and going to every single restaurant across the world to figure out wait times is not necessarily a great idea. So what they might do is they might look at all their restaurants around the world and then randomly pick some of those restaurants, and each restaurant would represent a cluster, and then find out the wait times of every single person in those restaurants that were randomly chosen. That would be a cluster. Let's say I want to know something about Mayfield. What I might do is I might go to the cafeteria where we have all our tables, right? I don't know why I drew tables like that. Our cafeteria is not totally like that. It's more long benches, but yep. And what we might do is we might randomly pick some of the tables and ask those tables a question. So maybe the question might be, if I want to know what's your favorite movie. The problem is, of course, kind of like the systematic, is that people who are friends would tend to sit at a similar table, and people in the same grade levels would tend to sit at a similar table, and they might not represent a really random sample. And so they might not give the same answer as the population. But that's a cluster sample. Next, we're going to do something called multi-stage. So let's say I want to pick 200 people from Ontario. Instead of throwing the 8 million people's names into a hat, which is simple random, what I might do is I might randomly pick a city first. So I pick Brampton, but it's random. And then I randomly pick a street in Brampton. So maybe I pick Beach Street. So I've randomly picked Brampton, and then of all the streets in Brampton, I picked Beach Street, and then I pick a number on it. So 192, and hopefully it's not nobody's address. And then I go to that house, and I randomly pick a person. So there's the 4 people in the house, and I randomly pick one, and that's the person who's going to answer my survey. So I've randomly taken, it's essentially a series of simple randoms. I've randomly picked the city, I've randomly picked the street, I've randomly picked the number on that street, and then I've randomly picked the person in that house. The advantage of that is the hat doesn't have to be as big ever, right? So how many cities are there in Ontario? Substantially fewer than 8 million. How many streets are there in Brampton? Definitely not in the millions. Not too many numbers. So I actually, overall, by doing multi-stage, it turns simple random into a more manageable affair. If I was going to do it in the school, if I wanted to pick 5 students in the school randomly, what I might do is I might pick a teacher randomly, and then I might pick one of their classes randomly, and then I might pick one person in the class randomly. So each person pulls a name out of the hat. And that would be a multi-stage. So this is what I'm talking about here is multi-stage. So there's multiple stages of simple random sampling. Next, we're going to have convenience. So convenience is when the sample that you pick is just convenient to you. So for example, if I made you, let's say I had an assignment and I said, okay, you guys, I want you to make a survey, and I want you to get 20 people, and I want you to find out how long they think this quarantine should be. So that would be a convenience sample. And what would happen is who would you pick? Would you pick random people from Ontario? No. I mean, you would randomly, that was an air quote, pick people who are your friends. You would pick people who were living close to you. If you went to a mall and I said randomly interview 20 people, would you interview the smiling happy person, or would you interview the scowling person who has a tattoo that says "Go away"? Right? You'll probably be like, okay, this person looks a lot more approachable. I'm going to interview that person. So that's a convenient sample. It's one that's easy for you. If you live in an apartment building, you go knocking on the doors. It's one that's most accessible. Convenience examples are mostly worthless. Then we have the last one, a voluntary sample. And a voluntary sample, the way that works is the people who are being surveyed select themselves to be surveyed. So you're not selecting the people to be surveyed, they are selecting themselves to be surveyed. So for example, if any online poll, if you have an online poll, then what's happening is that people are choosing to answer the online survey, right? If the question is who is what's the best animal in Animal Crossing, I'm not going to answer that because I have no idea about anything on Animal Crossing. But people who care about Animal Crossing might answer a little bit more. Right? Which video game is the best of all time? There's other issues with that as well. But so online would be that. Elections are also a form of voluntary sampling, because when you have an election, the people essentially we're sampling the population to see what kind of government they want, and the government there's nobody that goes around and asks a representative sample of people, who do you want? People select themselves to be surveyed, and we all write down our survey response on a ballot, and that's a voluntary sample. And those are different types of sampling. So remember, a good sample is going to be one where the sample is going to give the same answer as the population, and a bad sample is going to be one where the sample gives an answer that's different than the population would. So in the next lesson we're going to talk about bias, and bias is going to be something that causes a sample to give a different answer than the population.